Yeah, I want to thank you all, and thank you to everybody for taking some time out of your day to join my talk. I really appreciate that. There's really not a lot more to tell about me than what Elena already did. I am the director at Inspired Academy, which is part of Inspired Testing. We are a software testing services provider, mainly located in South Africa. 95% of our people are there. The rest of them are in the UK. And I am conveniently located in the Netherlands. So, it's all sort of kind of the same time zone. And with all these remote work options, it doesn't really matter all that much where you are anymore on the planet. As long as you can coordinate time zones and you have a stable internet connection, you can do a lot of things from basically anywhere. So yeah, I am going to talk about going big by thinking small, and how I think that thinking smaller instead of bigger might actually get you further in your automation, but also in your general software testing efforts. So yeah, why this talk? Because automation is everywhere. Everybody is talking about automation. We need to do more automation. We need to do automation faster. We need to write more tests. We need to automate everything. Everybody's talking, and we need bigger, better, bolder tools. So everybody's talking about wanting bigger things from automation, expecting bigger results, and everything needs to be automated. And that's a noble thought, but sometimes, unfortunately, it can lead you in interesting, strange, wrong directions. So in my talk today, I want to challenge that a bit. I want to give some examples of where I think actually thinking smaller is a better idea. Is a good idea, and focus on how can we make things smaller, and by that actually go bigger and achieve more and get more value out of the time and effort that we spend on automation and testing in the first place. So just a couple of examples of where people think and keep talking about bigger and more. I see so many people hiring. Everybody's hiring developers these days. Everybody's hiring automation engineers these days, because they all want to go faster. And so that's one of the examples of where. But yeah, if we just hire more people and more developers, and specifically to this topic, more automation engineers, we will go faster and we will get better results. This is where that poll came in very timely. Focusing on getting highest possible coverage. Everybody's talking about coverage. How much coverage does our automation give us? How much of our application, of our requirements, of our code, and whatever kind of coverage it is that you're talking about, people always want more. I don't think that's necessarily a good idea. And the third thing that I wanted to zoom in is the scope of tests, and writing large tests and writing large test suites, and demonstrating everything from end user perspectives, because that's really the only way that people think that's really the only way people believe that something can actually work. I could probably think of many more ways in which bigger isn't always better when it comes to testing and automation. But yeah, there's only so much time I've got, and there's almost only so much time to talk about this. So let's stick to these three examples, because yeah, bigger isn't always better. There are focusing on doing more, achieving more, hiring more people, putting more money into those projects, testing more, increasing coverage, increasing the scope of tests, and increasing your tools. It's not always leading you to the right. It's not always leading to the best possible result, and sometimes oftentimes really it's actually a better idea to think smaller. How can we make problems smaller? How can we do smaller things, take smaller steps? And by taking the smaller steps and by actually thinking smaller, actually end up in a better place than where we were when we didn't do that, or before we did that, really. Because sometimes, again, it is better to think smaller and not bigger. So the first area where I think as smaller is actually a lot better is when it comes to time and when it comes to scope. I'll explain those in a bit, but that's the first area where I think, well, actually, that smaller is a lot better than bigger. And that starts with me 15 years ago and me way less than 15 years ago, and a lot of people that I've seen, a lot of projects. I'm in the lucky position that I get to talk to a lot of automation engineers and teams and clients. And I see a lot of the teams in the same position that I was in 15 years ago, unfortunately. Put somewhere in, shoved somewhere into a corner with the task of automating all the tests. So I was literally given a stack of tests and say, well, these are the tests that were often regression in the form of regression test scripts that we want to cover, that we want to have automated because they're boring, they take a long time for us to do, so we want to automate it. So that's what I did. I started automating all of those tests. So I started writing code to replay whatever was being done in those test scripts and replace that with code that did that for us. And we were actually rewarded or punished based on the number of test scripts that we had successfully automated. And with successfully automated, they meant the automation script ran successfully without any errors or other kinds of things 3 nights in a row, which is a horribly useless way to judge the quality of the automation that you do. But that's how we were, how the progress of our test automation project was measured. That's the word I was looking for. How our progress was measured and visualized in long lists of these are all the regression scripts that we want to automate. The team, including a much younger Bas, is somewhere around 30% because they have 3 out of the 10 test scripts are now fully automated, so we never have to look at them again. And the reason why that isn't working, or why that wasn't working, is because a lot of focus was on big things. And because essentially what we built was a Rube Goldberg. This is a picture from the Wikipedia page describing a Rube Goldberg machine. And a Rube Goldberg machine is an unnecessarily complex machine or contraption that is meant to actually perform a very basic and simple task. And that's the literal definition of a Rube Goldberg machine. And at the moment when I was working on this project, I thought we were doing great things. We were building great automation, and we were doing so many wonderful, valuable things. And in hindsight, I think, well, we were literally building Rube Goldberg machines. And the reason for that had a lot to do with a lot of time. So a big period of time between the code that we actually our test code and the creation of the application itself. So there was a lot of time had passed between writing the application code and writing the test code, which means that developers have often moved on and they were busy building new features, and we still had to catch up with our automation. That's not the best way to have and to initiate and to have meaningful conversations about how can we best automate this. And because developers and your product people and everybody has already moved on to new features and maybe even new components and systems and applications, and you are still frantically trying to write automation for something that was created weeks or months or in some cases even years ago. That's not really efficient. And because you then have to make do with whatever it is that you have, with whatever kind of testability thing, and with the interfaces that are already there, with the the ways to, for example, inject test data that's already there, because there's nobody to have that conversation with anymore about how can we test this in the most efficient and effective way possible, because everybody has already moved on. And partly as a result of that, and partly also because what we were tasked with is the automation of existing regression test scripts. Is a lot of those test scripts, they were originally written by human beings for human beings. Which they were written by a team of testers. And they were meant to be executed by those very testers, or maybe by some end users, or maybe the developers chipped it, but they were meant to be executed by human beings. And the absolute worst way and most inefficient way of writing automation is, and that's what I've learned now, is trying to replicate with machines what humans used to do. Because and especially if you write that code weeks, months, sometimes years later than when the application was actually written. Why? Because again, there's no opportunity anymore. The opportunity has passed for having useful, meaningful conversations about how can we test this most efficiently, and how can we write efficient automation for this. But also because these scripts are then they're written by human beings for human beings, which meant they typically use graphical user interfaces as the way to interact with an application. And that's wonderful if you are a human being, because as a human being, you want a graphical user interface. And that graphical user interface is the only interface in an application that's specifically written to for being consumed by human beings. All other kinds of interfaces, databases, APIs, your code, they are meant to be consumed by other pieces of code or other systems, other processes, which make those interfaces much easier to automate, because they are inherently meant to be consumed by machines. And what we are trying to do when we try to automate these existing regression tests is trying to replicate what humans do with machines, using that only interface in an application that's explicitly meant to be consumed by human beings and not by computers. Because as we all know, for those of you who work in automation, who work a lot with tools like Selenium or Cypress or Playwright or whatever UI tool it is that you use, the UI is the hardest interface to automate. That's because it's meant to be consumed by human beings and not by machines. So trying to replicate that leads to all kinds of highly inefficient solutions, and lots of big scope tests that are not really all that efficient. And the problem, if you do it way after the fact, again, there's not often an opportunity to have those conversations about what can we do to test this and automate this more efficiently, because nobody wants to pay for reverse engineering that testability in the software, because everybody is going to prefer, well, let's add some new features instead. And so the only real chance, the only real opportunity you've got to talk about how can we most efficiently test this and automate this is while you are busy developing or designing or developing the software, or maybe even before that. But once that code has been delivered and shipped, the opportunity to have that to have that conversation is typically gone, because again, nobody, and I mean nobody, wants to pay for after the fact of reverse engineering testability into that software. So my advice again, I would be to write tests as close to the implementation as possible, and that means in time. So don't wait days, weeks, months, years with your automation efforts. Do that, have those conversations and work on it as much as you can in parallel with development, maybe sometimes even before development. Things like TDD, ATDD, and even to some extent BDD are means to write those tests, or as much of those tests as you can, before the implementation is possible, because that gives you so many more opportunities to talk about testability and how are we going to efficiently test and automate this while you are designing and developing the code. Afterwards, nobody's going to do that. So I keep that as close to the implementation as possible in time, and also in the scope of your tests. I'm not going to draw the automation pyramid here on screen anymore, but keep your tests as close to the implementation, as close to the behavior that you're testing as possible. And if you're going to do automation way later, there's probably not going to be a lot of opportunity to do that anymore, or it's highly unlikely that you're going to end up with efficient automation. So if you want to keep your tests as close to your implementation as possible, you need to do that as close to the moment when the software is written as possible, because that's the only way in which you can have that meaningful conversation. The second area where I think smaller is actually better or might just be better is coverage. I have a bit of a problem with the term coverage, and that's not just because I don't know what people talk about anymore when they talk about coverage, because there are so many different definitions of coverage. It can be requirements coverage, it can be code coverage, it can be behavior, all different kinds of coverage. But in itself, coverage is a difficult term. It's a flawed term in terms of testing, because it only tells me what part of my code has been executed. It doesn't tell me anything about the quality of the testing and the automation that I've done. And so just striving for higher coverage doesn't tell me anything that I'm actually successful in my testing, that I'm actually successful in my automation, because it doesn't tell me anything about the quality of the work that I do. A quick example, I've got a very simple piece of Java code here, a car class with a single property, horsepower, a constructor, and a method. That method that tells me, is that car a powerful car? And if the number of brake horsepower is over 400, I think it's a powerful car. Useless business logic, but it's just an example. And I've got a test that tests, well, I create a new car, 200 brake horsepower, and I'm going to assert that my car's powerful car is equal to false. Excellent. All tests pass, 100% code coverage, ship everything to production. Then next, after the weekend, Monday morning, your developers celebrated the successful go live of the application. And it's, well, we didn't really get to refactoring, so let's do that now. And they start refactoring. Monday morning, coffee machine is broken, so they have to they're running low on caffeine, but they start refactoring anyway, which is a very bad idea, by the way. And they refactor this code, and they make a mistake. Some developers do that. They make mistakes. That keeps us in business. That's good. They're human too. Some of them are. They make a mistake, and they refactor this code so that it accidentally always returns false. And they did, but they said, well, and they're obviously they're not aware that they introduced that error, that they made that mistake, but because, well, they have their safety net, they have their tests, and all the tests pass, and we still have 100% code coverage, but they never detected this error here. And why? Because again, that just A, the fact that your tests pass, and B, the fact that your tests present you with 100% code coverage, it doesn't tell you anything about the quality of the test that you've written. And I know that you immediately you see through this example, you said, well, I should have also had a test where I created a car with 500 brake horsepower, at least something over 400, because that test then would have failed. But in this case, it's really simple to see the flaws of your test code. But if all of your tests are passing and all of your code is covered, you might not think of that. You might say, well, I'm relying on my passing tests and the fact that I've got 100% code coverage. We are good to go. But that's just not true. It's again, because that code coverage, it only tells you about the number of lines and the amount, the piece of your, the percentage of your code that has been covered. So as Martin Fowler said way earlier, a test coverage is a great way to find untested code, but as a quality target in and of itself, it's pretty much useless. And I wholeheartedly agree with that. So at just striving for more coverage and talking about coverage as if it tells you anything about the quality of the testing that you do, I think is a really bad idea. And because it simply put, more tests does not equal better tests. I'd rather have fewer tests that I can really rely on, that I know that are absolutely trustworthy, than tests that give me 100% code coverage, but that I don't really trust, that I don't really know I will actually pick up on any of the on any unwanted changes. And so what I would propose is, instead of striving for more coverage, writing as many tests as we can, write as few tests as we can get away with. I'm not saying don't test anymore. I'm not saying just throw it into production and see what happens. That's sorry, that's not what I wanted to say. But write as few tests as we add. The key is as we can get away with. I think, again, think smaller, not bigger. Write fewer tests and then make those really good and really trustworthy, instead of just adding more and more tests because somebody once said something about a certain amount of coverage that we should have, that we should attain, because that's the holy grail when it comes to quality of our tests. I'd rather think a little smaller instead of bigger here. And it all comes down, in the end, it all comes down to this: who guards the guards themselves, and who makes sure that the tests that we do write, that they are our safeguards, our safety net. Who ensures that those tests are actually good safeguards, reliable, trustworthy safeguards. And just writing more tests does nothing to ensure that the safeguards that you're writing are actually reliable and trustworthy safeguards. The final idea, I know time is flying. final area where I think thinking smaller might actually be very beneficial is when it comes to team size and task distribution. So, and that all comes down to who writes the tests. I see it's a good time to be alive if you're an automation engineer. At least where I am and what I see of the market, mainly in Western Europe, because that's where I am, and that's where a lot of my network is. So that's what I'm exposed to on a daily basis. It's a good time to be alive because everybody wants test automation engineers. And everybody's adding test automation engineers to their teams, as well as developers, and they can't find the developers, so that then they do automation engine and they can't really find the automation. But everybody's looking for them. Everybody wants to expand their team because we need to, again, we want to do more automation. We need to do more automation. So what we need is more automation engineers. And adding more automation engineers, and just having the role of automation engineer in your team in the first place is an increase in scope and an increase in the level, the amount of distribution of the tasks that you have. But being a test automation engineer is actually a really challenging role, a really difficult role to play well. Being a test automation engineer or a software development engineer in test, which is the cool way to call yourself, but the cool role. But just being a test automation engineer is actually incredibly difficult because you're basically doing two things, trying to be in that split between, as an automation engineer, you need to be, I fully believe that you need to be a good software tester. Because what you're doing as an automation engineer is writing code that supports testing. And if you want to effectively support testing, you need to know what good testing looks like. And you need to be able to do that yourself, or at least have meaningful conversations with other members of your team about what good software testing looks like, what good software testing actually is, what good software testers actually do on a daily basis. And so you need to know about all of that as a test automation engineer. And then you also need to be a decent software developer, because what you do as an automation engineer, again, is writing code to support your testing. But you're writing code, so you are a software developer too, which means you need to have decent skills in the area of software development too. So now you basically need to be good at two things. You need to be a good software tester, and you need to be a good software developer. And that's, I've not met a lot of people that could do both really, really well. But everybody is looking for them. Everybody's looking for that elusive test automation engineer. And I've not even talked about ops kind of skills. So skills in Git and CI and Docker and Kubernetes and AWS and Azure, whatever kind of cloud platform it is that you're using. And I've not even talked about personal and business skills, communication skills, those kinds of things. When I see job ads for automation engineers, it often almost looks like they're looking for an entire development team and not just for a single person. But yeah, being a test automation engineer is a really difficult split. And what you get then is people who are mediocre at both or at all of these things at best. So unfortunately, a lot of the test automation engineering that I see, and they are all wonderful people, but they are often, they write mediocre code. They are not really interested in software testing anymore because they've moved on. They're now an automation engineer, which is much cooler than being a software tester. So they don't keep their testing skills. They don't sharpen their testing skills anymore, because they do all of this and they are too busy doing all the other. They don't have the time to really hone their software development skills and actually learn what it takes to write good, reusable, maintainable, readable code. right? Which is something I definitely think you need to do when you're an automation engineer. And that's just because we expect so much of these automation engineers. And we make this role way to come back to the theme of this talk, that we make this role way too big. And so what I would propose is, as a team, as a development team, and as organizations, I'd much rather talk about automation as an activity and not about test automation engineer as a role, because of all the problems that we've just seen, of all the things and the challenges that I've just addressed. It's looking for that five-legged sheep. And there are not a lot of five-legged sheep in the world. And if you, it's not really if it's, but once you found them, what's going to happen? They are going to be that one single person, or maybe if you're lucky, you've got two, who do all of the automation. And the developers then are more than happy to push all of the testing and the automation work to those people, because they are the automation experts. And the testers say, well, I don't want to know anything about automation. I get back to testing. And they too distance themselves from what is being done in the automation department. So you get silos again. Your team gets bigger, the responsibilities get distributed, you get all these silos, and not a lot of communication is happening anymore. And so instead of, and what I would propose is, instead of doing this, instead of appointing dedicated test automation engineers and giving them, tasking them with all the automation, and I know it's fun, I've been there, I've done this too. I love writing automation. Seeing those tests pass and knowing that those tests are actually going to contribute is wonderful. But for team dynamics and collaboration and knowledge sharing and having meaningful conversations, it's often, I'm not ready yet to call it an anti-pattern, but I think it's definitely something that a lot of teams should reconsider. I'd much rather see them work together, see developers and testers work together and pair up in writing code and testing that code, in having those conversations about what is it that our new feature is going to have, is going to do, what is it that, how are we going to test that? How are we going to test that in the most efficient manner? And then the testers can, if they work closely with developers and are able to have those meaningful conversations, you don't need a separate role somewhere in the corner of your team room and where that is tasked with all of the automation, because it happens in those pairs. And that can be the developer writing the code, maybe it's the tester, and you get immediate feedback, immediate reviews, and much smaller and shorter feedback loops again, which we also talked about, and which I also talked about a little bit earlier today. So, and I think we are right on time. And so when it comes to, we've talked about feedback loops, we've talked about scope of tests, we've talked about the time it takes between writing your application and writing your tests. We've talked about coverage. We've talked about team size and distributing tasks. I think these are all examples of where we can actually, I would recommend start thinking a little smaller, think small, and do as little as you can. And instead of thinking big, instead of just blindly adding more tests, instead of blindly taking existing tests and trying to recreate those in automation, instead of looking for that automation engineer that's going to do all of that for you. I'd like people, I would love for people and for teams and for organizations and for us as testers as a whole to just think a little smaller, because I really think that can do a lot in helping you make it big. That's it. I think we are right on time. Do we have time for questions, for Q&A?
Sure, we have time. And, you know, but I don't see something right now. However, I'm having a question. So I can begin until a question may drop.
Sure.
From the audience. It was really very interesting and very important talking about testers working closely with developers, automation testers. But I was just considering if in this case we may miss maybe they will be built upon wrong assumptions, both of them. I mean, losing this independence, how we can we can be sure that they cannot go through wrong assumptions and that the independent mind of tester will keep be there?
That is a really good question. I think that actually improves when developers and testers start working together more closely and start working in pairs or in small groups closely, because you immediately have that conversation and that feedback and more than one pair of eyes on whatever is happening at the moment, be it writing code or be it testing. Another problem or challenge with having a separate, I'm all for having separate tests. So I don't say, well, that one person should do everything. And that's why I propose having a person who's good at development and a person who's good at testing work together more closely and have those conversations instead of doing things asynchronously and almost farming out the automation and the writing of the tests, the automating of the test parts to yet another person, because I think that that's where assumptions are starting to be made. It's much easier to, and that requires some skill, especially communication skills. I'm fully aware of that, but asking those questions and being comfortable asking those questions when you work together and when you pair up, where you work in groups, to just say, well, but what about this situation, or what would happen if we do, if a user would do that, or have we thought about what would happen if this event occurs? I think that actually reduces the number of assumptions that you make, because when people are starting to do that work asynchronously, so developer develops, then tester tests, and at some point in time automator automates, there's a lot more room for assumptions.
So yeah, okay, you're so correct. Thank you. I'm totally covered. Thank you, Bas.
Okay, so we have also one more question. By the way, Bas, that was really nice. That was a fantastic presentation. Thanks a lot for that.
Thank you for your kind words.
Umut has a question. I gave you the permission. Can you please try?
Hi.
Hey, Umut.
Hi. So I would like to actually go back to the topic and put the question in the other way around. What if they are not working together? The tester or the test automation engineer and the developer, and they understand the same requirement or the same so-called ambiguous request differently, and everything, tests are written different. The functionality is focusing on a different aspect, which both might miss the mark of what user is also requesting. In that perspective, I am more thinking in an agile term that more or less everybody should be able to do everything kind of a sense, which is not the reality. But yes, in your team, you should have some variety in the skills.
Oh yeah, absolutely.
If your tester do not understand the concept of the operation, or let's say the business logic, and the IT logic behind it, there is always a missing window that you're not able to cover. I agree on one perspective that the less is better in the amount of numbers of tests, but I think that the quality should be more. So what is counted, the metric of the testing, shouldn't be the number of tests, but it should be some kind of coverage or the risks that are reduced with the test.
And that's exact. I don't. Thank you for your contribution. I don't actually see that as a question, but as a very useful contribution to what I talked about. So thank you for that.
Yes, it was not actually the question, because just after the last question, I was thinking, what happens if they do not click? Because the previous question was, what happens if they do the same wrong assumption? And from an operational or project perspective, what happens if they do not understand the same thing from there? So they do not come up, handshake the assumption. Before the assumption is done, maybe two people agreeing each other, what does that mean, can give you a bigger effect. And on that part, it is not also about the developers, one developing software, the other one developing the test, but generally the team coming together and agreeing on what the piece of software is supposed to do is a better synergy.
Absolutely agree.
Thanks.
And this is, by the way, you are perfectly describing the whole purpose of BDD, by the way. So having those meaningful conversations up front before you even start designing and developing your code and your tests with a developer, a tester, and a product person, which can be a product owner, a business analyst, maybe even an end user, someone with a business perspective. And by working using examples, because that examples leave the least room for assumptions and for that's exactly what BDD is all about. So but that's more generally, it's all about having those conversations and looking at things from different perspectives. But it's all about the whole collaboration thing. So yeah, thanks again for very valuable contribution.
Thank you. It was a great presentation.
Umut, thank you for your great question and contribution. Bas, there are also other questions at the Q&A part. Can you see them? But I'd like to remind that there is no time to left for the Q&A session for this session, but you can type your answers down there.
Yeah, absolutely. I'll take some time to do that right now, right after this. But I think we have to move on with the program.
Yes,
isn't that correct? No, absolutely. I'll stay online. I hope that means I still have access to those questions, and I'll answer them in the Q&A via the Q&A functionality. No problem at all.
That would be perfect. That would be perfect. So, so we are moving on to the workshop, and I'm going to upload the links if you haven't got any yet. So
awesome. So just one final thing that I wanted to share here. If I'm not sharing my screen anymore. I see. Okay, that's good. People know where to, people probably, if you look me up on LinkedIn or anything, if there are any questions that pop up at any later point in time, just find me there.
Yeah.
I spent too much time on there anyway. So
yeah, thank you a lot for.
Thank you all, and thank you for having me, and enjoy the rest of the conference.